let's focus a bit more on correlation itself. There are 5 requirements that we must meet if we're going to look at correlation. First, the data is from quantitative pairs. So we have to have numbers, and it has to be paired. We already talked about spurious correlations, fake correlations, when we did not start out with paired data. Second, like all good data, the data has to be from a simple random sample. Third, we're going to do a visual assessment through a scatter plot that the data approximates a straight line. We've done visual assessments before, like assessing for normality by looking at a histogram, a box plot, and a probability plot. This time, the only plot we'll look at is the scatter plot. Our data does not have to be a perfect straight line, and we'll look at lots of examples to get a better feel for that. The fourth item, correlation is really affected by outliers. So if there are any points that appear to be outliers, we need to double check that they're not errors. It's easy to have typing errors when we're typing quantitative data into Minitab or another software program. Remove the outliers if they are errors. However, if they're not errors, you have to let them there. And then finally, we'll find the correlation coefficient. This is a value that describes how well the data fits a straight line. And we'll also find a p-value. So yes, that means we're doing a hypothesis test. In this particular video, though, we're going to focus on that visual assessment through the scatter plot and get an idea of what would approximate a straight line. We'll also relate that scatter plot to the correlation coefficient. We're going to visit a website. You're welcome to pause the video and type this website into your browser. We'll look at a few things here in the video, but there are many more great pieces of information at this website. So here we are at the Math is Fun website. We're looking at correlation. It says when two sets of data are strongly linked together, we say they have a high correlation. The word correlation literally means together, relationship. So there's a positive correlation when the values increase together. Right here we see a perfect positive correlation, the values increasing together in a perfectly straight line. And we give that a correlation coefficient of 1. We get a negative correlation when one value decreases as the other increases. And we see the perfect negative correlation at the other end here. So these guys are going downhill. So as the x value increases, the y values are coming down. And again, it's perfect because it's an exact straight line. We see a correlation coefficient of -1. In the middle, we see a scatter plot where it is not even close to a line. It appears to be totally random. And we see a correlation coefficient of 0, which is no correlation. Our correlation coefficient values can always go from +1 to -1, with 0 being exactly in the middle and meaning that there is absolutely no correlation. The values are not linked. Now, that correlation coefficient tells us how well the values fit a straight line. So here we see a high positive correlation, and these values, they're close to a straight line but not perfect. And here we see the R value for the correlation coefficient has gone down because these are a little bit further from a straight line. And then we see the mirror images in the negative direction, though. So here a little further from a straight line, correlation coefficient -0.3. Here, very close to a straight line, correlation coefficient is high with -0.8. So the value shows you how good the correlation is. And if it's a positive or negative correlation. See these positive values, positive correlations, negative values, negative correlations. Again, I invite you to come back and explore this website some more. There's lots more information on it, but that's as much as we're going to do in the video.